Hey everyone, I'm Clue. Welcome back to Minecraft, still working on the data pack project. We're going to do a bit of optimization in this episode. So I've been given some pretty helpful advice from Statistically Blue about how to optimize my pack further, which is great. So we're going to tackle those changes. But before we get into that, he's also showed me how to properly debug. So I am going to start by creating a benchmark, right? So if we go ahead and do F3L, there you go. It says debug profiling started for 10 seconds. Use F3L to stop early, but after 10 seconds, it will essentially generate a report telling us the ins and outs about our tick lag, essentially. So the easiest thing to do in terms of a benchmark is to just use the ticks per second, right? So we're still, fairly high. In fact, that was probably a bit errorsome because usually there's a bit of lag. Sorry, new hotkeys too, right? Because it's F3.2 instead of Alt F3. Right, yeah. So when you initially load a world, there's going to be some upstart lag. So we'll do it again, right? And it should be hopefully a little bit higher. And we'll use that as a benchmark. I also want to test the arm set pack, just standalone, and then we'll test Runechant. Then I'll implement all the changes that he's sort of gone over. There you go, 502. Right, so 502 is essentially our benchmark. This is a normal Minecraft world, nothing loaded. But if we go ahead and compare it now to, we'll do the arm set effects first. Right, so if we go F3.2, you can see there's those spikes, right, when the game first loads. If we let it run just for a little bit, I mean, it looks like we're in the clear. So we'll do another debug report, right? We compare the two. I'm probably not going to clean up this pack, in all honesty, right? Because my main attention is on the main data pack project and to implement the changes that Statistically Blue has outlined. Oh, that's interesting. This is running better, apparently. We'll do it again, just in case. Maybe I should have done the normal world again. I'll probably do the normal world again at the end, right? Just to try to create some consistency. But yeah, I'm only going to be tackling changes for the main pack. 630. We'll compare the two properly. Okay, and then on to Runechant, right? Which should be pretty bad. That said, if you can't tell, right? Because even this one is pretty horrendous, but it'll still be over 20. Because my computer is fairly decent. Again, I like to say high mid, right? It's not a high-end computer, but it's not, a low-end computer. But yeah, so this world is a little bit worse. So we'll do the debugging report. Might as well look at stuff I have added while we're at it. Been doing more of the art stuff. Where's my little chest? Down here. Right, so I've updated the spell books. We now have 3 variants. I've also done the trimmings for the normal enchant books. So you can trim them, essentially make them stat sticks. Oh, what was the results? Yeah, 212. So definitely down compared to the other two, but still above 20, right? So there's no tick lag in reality, but it's still pretty bad, right? If you compare it, it's a third of the possible tick speed, right? We'll just do the normal world again, just to double check. So again, it's just F3L to debug, and then we'll generate a report, which you can click on, which we will do. Right, so after 10 seconds, there we go. So 540. So it's still less than the armor sets, which is interesting. We can open that up, although you guys can't see. Where's my little folder one? There we go. Right. Although it's not centered. Why is it not centered? It should be the whole screen. Anyway, these are all the different reports, so I can go through them, take a closer look, but I will start implementing the changes. And then we'll probably go over what exactly they are. Essentially, he's taught me how to properly handle checking NBT through some storage mechanisms and better ways to run scoreboard checks. Right, so I'll get to work, although you can't really see my hand. You can sort of see it because I left the folders. And then we'll go over those changes and hopefully it's a lot better. Actually, before we do, right, we'll go through the reports because this is a little bit better. Right, so if you just click the little link that pops up, it brings you to the folder where they all are. Right, so we've got Runechant, normal, armor sets, right? And you can go into any of them. So if we're going to Runechant, then client, profiling, and it says your tick span, right? So approximately 231 ticks per second. As long as it's over 20, you're golden, right? It says speedy zoom. That's the quickest and easiest way to sort of understand what all this is. Again, no computer science background, so this is what I'm using for my understanding. Compare that to the normal world, and it's actually higher than what it was reporting in Minecraft, right? So it's 910. So it is pretty substantial, right? It's 1/4 of the speed of normal Minecraft. Then if we look at the armor set ones, client, then profiling, 665, right? So still less than normal, which is what we should expect because it is a data pack. and then more than the full data pack. The one thing to note though is neither of these data packs are technically active, right? Because they're not actually performing the strenuous functions. The ones actually check your data, right? You have to equip the armor for those checks to actually work, and then same with the attributes. The attribute mechanisms sort of like toggles, right? So they check it once and then they lock, and then they don't update until you update your armor. So in that sense, you know, this is probably the best it can be, right? And it's only downhill from here once we actually start making use of features in the data pack. So that is worrisome, right? Because again, if we just look at it in the ratio from normal Minecraft to it being 1/4 is pretty substantial, right? We want some semblance of reduction, right? But not 1/4. So yeah, I'm going to implement the core changes that Statistically Blue has outlined to me, and hopefully we can get these two numbers a little bit closer. Let me explain the major change that we're going to make, right? For anyone else there like me who's, you know, novice at this at the moment, right? So what Statistically Blue has taught me is the storage command, which to me was very confusing because again, no computer science background. So I think in proper sentences, if that makes sense. So like the way that a lot of this is set up to call upon different things, right? Doesn't make sense language wise for me because, you know, coding is usually considered a different language, right? Because there's a whole bunch of different grammatical, you know, schematics and different things that you need to make sense of and learn to actually use it properly. But what are we doing? Execute as at all, right? Run data modify storage. I'm just calling it Runechant play. You can call it whatever you want. And then player.nbt. Now, I'm not too sure about this because you can just do NBT to target NBT. I don't know if player is just used to specify the player rather than say something they're writing or other entities. If you change this from at all, I'm pretty sure if I change it to at E, it will only do players, right? So we're storing all the NBT from at S. Then from that, right, if I click the button, we can now run a command like this, right? So execute if data storage, Minecraft Runechant underscore player, then any player who has the tag high will be given the effect glowing, right? So if we run that, we get glowing because we have the tag high, right? All our NBT data has been stored into that .json, right? Did I get that right? Right, so we have the tag high, and then we're calling upon it here from Runechant underscore player. So this allows you to essentially check NBT without rescanning or rechecking every single player, which is something I do heavily, right? In fact, our last discussion on TPS was essentially me condensing it, right, to where I was just running one check and then using at S. But as I've been told and taught, at S is better, but it's not the golden rule, right? The golden rule is to store the data and then read it from storage rather than rechecking the player because there's a lot of different bits of information to process and go through, and that generates a lot of tick lag. So essentially what I have to do is I have to go through the entire data pack, right? And anywhere I'm performing these checks, which is essentially everywhere, I need to change it into essentially this if statement, right? And then anything I'm looking for, I just need to put in here, and then it'll automatically check against every player because I will just run this as a blanket command so that it always constantly stores everyone's NBT, right? So if you're on a server, it'll store all the players' NBT. If you're single player, it'll store your NBT. Now I'm curious about just using at E, right, and storing entities. I looked at the wiki and it says there is a limit of 2024, right? Was that 2 gigs? Because it would be in bytes, right? The storage size. I think I'm close with that, right? So I'm curious about entities. I could set up a way so that it stores and deletes, stores and deletes, stores and deletes, but I don't know how much lag that will cause. So I think we'll tackle it in stages. We'll implement this, see how well it performs before we touch the entity side of things, because I do have the pack separated, so I can easily go through just the functions that do target the player and check off of the player. And then there's also the scoreboard system that I need to tweak. Essentially, the way I have scoreboard set up, right? We do scoreboard objectives. We'll do that. Add. I'll have a dummy player, which is the wrong way anyway. But yeah, so we'll have no. I need to do a players. Try again. We'll do add. Right. So we have a dummy player, which you can name anything, and then the scoreboard. You want to use special characters, which is something I did not know, and I need to start using. Because if you put it in a special characters can't be used in usernames. Therefore, these are always dummy players, and they cause less lag. So I've been, again, taught. So yeah, I need to go through, change all of them, have one dummy player, right? So it'll probably be hashtag timer, right? And then have other way around, have a scoreboard called timer, and then have a bunch of dummy players. So if I want our 3-second timer, for instance, it'll be hashtag timer 3 seconds, right? But there's only one scoreboard that's updating for all these different timers, right? So condense these all into one timer, and that way it should run a bit better. I need to look it up because I'm pretty sure there's a limit to how many entities can be on a scoreboard, right? But yeah, that should also aid in the lag. The big thing though, that he explained to me is storage, right? Using the storage function rather than checking entities and checking players is going to cut down immensely on the lag.